Hi everybody, welcome to the second calculator tutorial in Math 1342 Statistics. In this video, we'll go over three things. The first is the combination and permutation. Second, binomial distribution. And finally, normal distribution. First, combination and permutation. Right. So we have this problem. The first thing we have is we're going to select 5 letters from this word. This word will have 1, 2, 3, 4, 5, 6, 7, only 7 different letters. So we'll select 5 out of 7 because all of the letters are different. Order does matter, and so we use permutation of 5 out of 7. Right. Now we use the calculator. So first we have to hit the bigger numbers first, 7, and then go to math, probability tab, option number 2, and then we hit 5. That will give us 2520. So that is the TI-84. Now let's switch to TI-83 to see if there's any difference. So again, I'll hit 7, math, probability tab, option number 2, and 5. So pretty much will be the same on 2 calculator. Right. I will switch back to the TI-84. Right. So we test that. Next, there are 5 women running in a race. How many different ways could first, second, and third place finisher? Again, we will have first, second, and third place. So which means order does matter. Just like the first example. And if order does matter, all the rows of each of the letters are different, or all the then we say this is a permutation. And we have first, second, and third, meaning we're going to select 3, and will be 5 women in a race, so be 5p3. So again, we'll hit the big number first, and then math, probability tab, option number 2 and 3. So test that. Right. Next, there are 5 members on the board of directors. If we must select 4 members, a subcommittee of 4, so out of 10 members. Now, this is a committee, so the roles of the members in the committee are the same. So orders does not matter. Or because the roles are the same. From this we use combination. Right. And we select 4 member, and this is a combination, and we select from 10 members, so combination of 4 out of 10. And similar to the permutation, the calculation, we enter the big number first, math, go to the probability tab, and choose option number 3 for combination. So I hit 3 and then so 4. If you using the TI color 84 with colors, it's going to look a little bit different, but just enter the big number first and then the combination or permutation and then the little numbers, and that should be right. Right. Next, physics exams. I will have 9 questions, 9 multiple choice, and 6 essays problems. If if we have to choose 7 multiple choice questions and 4 essay questions, how many way we can do this? So pretty much we're going to have, first of all, this is the multiple choice. And then we have essay. I think it's out of ink. Sorry. Right. So for multiple choice, there are 9 questions, and we have to take 7 of them. In essay, there are 6, and we have to choose 4. Doesn't matter what we choose in the multiple choice question, does not affect what we choose for the essay problems. So we have C of, combination of 7 out of 9 times combination of 4 out of 6. So let's put the parentheses in this case. 9. I just do one by one. So 9 7, combination of 7 out of 9 is 36, and 4 out of 6 for math. Sorry, we choose out of 6 questions 4, so always put the big number first. Right. And that's 15, and so we have 36 times 15, so just multiply 540. Right, so very straightforward. Next, a pool of possible jurors. We have 15 men and 10 women. Find the probability of 12, and that in particular there's 5 men and 7 women. So this problem we have to do in 2 parts. The first one will just select 12 people out of, now we just choose 12 people out of 25 with any, it doesn't have any restriction. It could be 12 men or maybe 10 women and 2 men, or any combination, so it doesn't matter. So in general, we will have C of combination of 12 out of 25, and this will be the sample space, will be all the possibility So be all possibility, and that is the sample space. Alright, so we're going to do that. Let's just say it might be a big number, 25. Right, 5,200,300 ways to do that. Now in this particular, we only want to have 5 men and 7 women. So we're going to have, just like this one, we're going to select 5 men out of 15 and 7 women out of 10. So we do that. Let's put both of these together. 15 combination of 5 out of 15 times 10 we're going to choose 7 women. So pretty much we multiply those two together and we have 360. Right. And finally this problem asks for probability, so we're going to take this much divided by the sample space. So we have probability equal to 360, 5,200, 1,300. And we have about 6%, 0.0693693. Suppose that number on that side. Right. So if the question asks for the probability, we have to find the sample space on possible way to choose 12 people out of 25. And after that, in this particular event, we have 5 men and 7 women, and we have that much, and divide them, we're going to have the probability. Right, so all of those are the question examples for combination. Now we go to the second part. We're done with that. Now we're on to binomial distribution. We have this question. What is the probability that 19 tosses of a fair coin and will show 8 heads? Right. Let's clear the calculator. Right. So, binomial distribution, we're going to have n, p, and x. So n, in this case, number of trial, 19. Next, it is a fair coin. So we're going to have 50% chance of getting the head, 50% chance of getting the tail. Let's consider, let's say the head in this case is p, so 0.5 chance, 50% chance of getting the head. And x, of course, it's going to be 8 heads. So we have that. Now we just put in the binomial PDF, and the syntax is this one, right? So we hit on the calculator. Second variable, option A, we can roll down and go to option A for binomial PDF, or if we know for sure it is A, we just hit alpha and then math. That is, go to the letter A here. That go directly to binomial PDF. Right. Number of trials 19, probability 0.5, and x values 8. So it will be like that. Binomial PDF 19, 0.5, 8 equal to 0.144. Right, so that is using the TI-84. If you're using the TI-83, this might look a little bit different. Right, so still the same. Second variables, option A. So we can go down to A. Actually, different option now in this TI-83. So we have binomial PDF. Right, and then we enter. Of course, it did not ask for the question, so in this case we have to put 19, 0.5, and 8. So 19 for n, p is 0.5, and x is 8. So TI-83 will do like that, and we have, of course, the same thing. So that's why I write the syntax on that side. So binomial and px in the alphabetical order. Right, so we have that. Right, next. In a certain college, 30% of the physics majors belongs to minorities. Find the probability that a random sample of 10. So we select 10 physics majors. So that means n is equal to 10. Exactly 4 do not belong to the minority. Right, a little bit twist here, but anyway, so probability and then x. Now, have to be clear here. This one we want 4 do not belong to are not minority. So if we say 4 is not a minority, and by that minority I mean the ethnic minority, not major and minor. That could be confusing, but so ethnic minority and 4 do not. Now in that case, the probability will not be 30%. The 30% here belongs to the ethnic minorities. So the complement to that is, we have to write 1 minus 0.3 is 0.7. This is not minority. So it's very important that the probability and of p and x have to be the same. So we have 0.7 not minority. So the probability of not that person is not a minority. So have to be clear. And once we have npx, it should be very simple. I just keep the TI-83 here. second variable option 0 in this case, so just go down. Option 0 binomial PDF 10 comma 0.7 comma 4, and we have about 3%. Three, 6, 8. Right. So note that the probability of success and this must be the same. So we cannot put 30% here. Right. So that was 7. Now go to 8. Right. Right. A test have 10 true-false questions, and to pass a test, a student must answer at least 7 questions correctly. If a student guesses on the question, what is the probability that the student will pass the test? So first, there will be 10 questions. Usually n is very easy, and x, in order to pass, we have to have at least 7. At least 7 meaning that x can be 7, 8, 9, or 10. And like that, we need to note that those we have to have 7 the answer correctly. Now the probability. This is the true-false question, meaning there is 50% chance of getting it right. So 50% chance because we guessed the question. 50% chance is correct and 50% chance is incorrect. So here we write 50% chance of getting a correct answer. Again, those must be the same. Right. Now we're going to keep the TI 83 here. So binomial PDF of 10 number trial, probability 0.5, and then we're going to enter the list of number that is 7 to 10. You see the comma parentheses right here. So in this on that side. So we open, so second parentheses, we're going to enter 7 comma 8 comma 9 and comma 10. Second parentheses to close it, and then hit enter. Let me write it down. Binomial PDF 10 0.5 open 7, 8, 9 and 10 close. And then we just need to add all of this up. So to add will be second stat, and option, go to the math tab, option number 5, and then we pretty much add everything. So we hit second and the minus sign, I mean the negative sign. So we have that. So this is how we enter in the calculator. Right, we already know the binomial PDF the summation, the sum is second stat go to math tab, option number 5, sum. And to get to the answer, we're going to just need to hit second and the negative sign. That gives us the last answer we have on the calculator. And the curly bracket is the second and the parentheses. Right. So it will be 0171875. Right. Now I switch the calculator. I'll try the same thing. Second variable, option A in this case, so I just go down here. There will be 10 trial, P probability 0.5, X values, open curly bracket, 7, 8, 9, 10, and close the curly bracket, and paste to the home screen and hit enter. So we're going to have that. And then we just need to add all of those up. So second statistic, go to the math tab, choose option number 5, and then second the negative sign for the answer. And of course we have the same thing. So that's good and all, but this I haven't shown you in class yet, but there's another way to do this using the binomial CDF, which we haven't used in class. Right. A bit confusing here, but so let me just write a note here. Use binomial CDF. The syntax pretty much will be the same. Will be N, P. This is going to be tricky. The CDF, the C stands for cumulative. So what it does is actually whatever numbers we put in here, it will calculate everything from 0 to x. Actually, this is the same as 0, 1 on the way to x. So for this problem, this is, if we're going to use binomial CDF, we have to do it like this. If we use binomial CDF, we're going to enter 10, 0.5, and then 6. And you will ask why it is 6. Right. No. What it does here is that this is the C, so we will sum all of the binomial PDF. This is the CDF and this is the PDF of 10, 0.5, and go from 0 to 6. So the cumulative will do from 0 to 6. And so we do that. Oops, sorry, the CDF. Uh, 10 trials, probability 0.5, and X values is 6. When we do that, we get everything that is from 0 to 6, and they add all of those numbers for us already. So the binomial cumulative distribution function, it will add everything from 0 to x. In this case, add 0 to 6, we have that. And what we actually want is from 7 to 10. So we take 1 minus this. So pretty much the complement. Take 1 minus 0.828125. We just do 1 minus second negative sign, and that gives us the same thing. Our bottom line is the binomial CDF will add everything from 0 to that number. And if we just want one particular number, that is going to be PDF. I'm afraid that you might confuse in class, so I did not show you this, but this is also possible. So right, notice that just in case if you use the CDF, it goes from 0 to x, pretty much from the left. The calculator by default, when it talk about the cumulative distribution function, it's going to be from the left. Right, keep that in mind. That will come handy for the normal distribution, which will go next. Now, normal distribution. So we done the binomial distribution. The last part is normal distribution. Right. So and it's going to be under the same menu second variable. We have the normal CDF. Notice that we only do the CDF here. Right. Let's go. First, if it is standard, we're going to have the z values, and we have between two z values. So pretty simple. So binomial, sorry, not binomial, normal PDF, and we go from this to this. And the syntax is normal CDF. This is CDF, sorry. It's binomial normal CDF. It is a C, not a P, because the cumulative from negative 1.25 to 1.25. Right. So it's going to be the second option, normal CDF, and it goes from negative 1.25 and to 1.25. That will be enough. We do not need to change the mean and the standard deviation, because this one is standard. 0 for mean, 1 for standard deviation. So we just paste. We have that. Right. Notice that we don't really need the 0 and 1 at the end. We can delete that. So if this is the standard, we just have those two numbers. Right. Now let's switch the calculator. Right. It is going to be the same. Normal CDF of negative 1.25. The TI-83 doesn't give us the prompt for the question, so we have to know the syntax, and the syntax is on that side, the normal CDF. Let me highlight it. That. Right. So 1.25, comma 1.25, and that's it. If it is standard, we don't need to specify. Even if we want to specify, it's going to be the mean is 0, the standard deviation is 1, it's going to be the same thing. So the syntax, let me write it here. Binomial CDF, we have the lower values, lower number, it could be x, it could be z, and then the upper, and after that we have the mean and the standard deviation. So that is the syntax. Next, find the area. So the area or the probability is going to be the same. Area under the curve and probability. This one on the left of z equal to negative 0.25. Again, this is z, so it's going to be the standard, and it does say standard, meaning the mean is 0 in the middle. Therefore, the negative 0.25 is here, and we want the left of it. So we want this area. So pretty much like what we do here with, however, if we're going to do the binomial CDF, we have to write numbers here. We designate negative 999 will be a very small numbers, and that will do it. So we enter negative 999 goes to negative 0.25, the mean is 0, the standard deviation is 1. We don't really need to write that, or we just delete those, still doesn't matter. So we have the area is 0, let me just write down. Right, so we have that. Usually we'll take 4 decimal places. Will be enough, be good enough. The next one will be the same thing, but this time we have the mean and standard deviation. We'll calculate this. So this is not standard. But the mean is 100, so we know in the middle is 100. We want the values that is bigger than 112, so let's say 112 is about here, and we want bigger than 112. Just like the last problem, we have to designate a big number on the right tail, on the right side and the left side. So normal CDF, that goes from 112 to 999. Actually, it might not be self. I just put another 9 here. If it's non-standard, especially those numbers are big, we have to choose a bigger number just to be safe. Right. The mean is 100. The standard deviation is 15. So we'll do that. Keep the TI-83 here. By our normal CDF, that goes from 112 to 9,999. The mean 100. Standard deviation 15. So we have 0.2119. Right, let's switch back to TI-84. Right, so second variable, normal CDF 112 9999, the mean 100, standard deviation 15, and we have the same thing. So the normal CDF will calculate the area, the probability, the proportion of the population. All of those mean the same thing. Actually in the next one as well. So find the probability that it is greater than 212. So we have the mean and the standard deviation. This one probability. So we're still using the normal CDF here. And we have the mean and the standard deviation, meaning this one is non-standard. The mean is given 170 and we want more than 210. So the area will be normal CDF 210. That goes to let's again 9999, and the mean is 170. Standard deviation is 30. Again, if you using the TI-83, you need to know the syntax. Again, let me highlight that. Okay, that is the syntax. So second variable, normal CDF 210. That number is good. 170 and 30. Right, so it is like this. Normal CDF 210, 9999, 170, 30. So have about 9%. Usually 4 decimal places for the probability is good enough. Right, so probability is the normal CDF. The area also normal CDF. The proportion also normal CDF. Right, now the next part we need to find the z-score. So this is not normal PDF. Right, so in this case what we want is we want to find the area to the right, 80% of the distribution area to its right. So we have on the right side 80%. So we have 80% on the right here. Right. So to find the z-score, we're going to find the inverse normal. We use the inverse normal option. And in this case, we want the z-score here. Notice that very important things in the inverse normal. Whatever we put in, it has to be the area on the left. So we need to have this area on this side. Since 80 on the right, there must be 20% on the left, or 0.2. So the inverse normal, all we need to do is just 0.2. That will be enough, really, because this is a standard for the z. We don't need to specify the mean and standard deviation. Anyway, second variable, option number 3, for inverse normal, we have the area on the left 0.2, and we have negative. Notice that this is the z values. It could be negative. The area probability cannot be negative, but this one can. Right. And notice that in the syntax, we really don't need to specify the mean and the standard deviation, because in this case it is standard. We ask for the z values, so it is the standard normal, and it gives you the same thing. Right. Let's switch to the TI-83. Second variable, the same thing. inverse normal, we just need to specify the area on the left is 20% or 0.2. Or we can also write 0.2, but we specify the mean is 0, the standard deviation is 1. It doesn't do anything, still give you the same answer. So if it is the standard, we do not need to specify the mean and the standard deviation. Right, this will be last question on the video. The body temperature with the mean is that. So we'll write the mean is 98.6. Now we know the mean here, so this is not standard, degree Fahrenheit. So this is not standard. Standard deviation 0.95. Degree Fahrenheit. So this is not standard. What temperature represent the top 90%? So we want the top 90%, meaning 90% on top, 90% on the right. And just like the last problem, if we want to have whatever the values here, by the way, because this is not standard, this is not Z, it is X. And we do know that the mean is 98.6. So whatever we have for X is going to be a little bit less than 98.6. Right. So it's going to be inverse normal. Since the area on the right is 90%, on the left it must be the complement to that. So this is going to be 1 minus 90%. I mean 100% minus 90% is 10%, which is 0.1. So inverse normal 0.1. This problem is not standard. We have to specify the mean and the standard deviation. So inverse normal area 0.1% on the left, 98.6 and 0.95. So we have 97.38. Of course, that would be the X values. It will be a little bit less than 98.6, which is to be expected. Right, so that is the TI-83. The TI-84 will be the same. Inverse normal 0.1. That is the area on the left. The mean 98.6 and the standard deviation 0.95. So that is the syntax. And we have the same thing. Alright. So pretty much we cover everything. Again, combination, permutation, that's the first part of the video. The second part, binomial distribution, and the last part is the normal distribution. Right. All the note on that side and calculator throughout the process. We use both TI-83 and TI-84 will be on that side. Right. I hope this video will help you to prepare for the test. Of course, there will be a lot more on the test, but the part that we need to use the calculator will be mainly covered on this video. I hope it helps. And as always, thanks for watching.